All right, so we're going to be looking at what conics is and how the different conics come about, and then we'll focus on ellipse. Then in our next video, we'll look at the parabola fully and then the hyperbola fully. So please stay tuned to the end of this video and I assure you, you would not regret it. Now, what is conics or conic section? Now, these are curves formed when a plane cuts through a double cone. That is a cone with two naps. Now, if you look at what I sketched, you will see two cones with what? Two naps, right? Joined at their naps. Okay? So now, what happens if I use a plane to slice this cone at different places? All right. So this conics is actually coming from the word cone. So our focus is usually everything, every shape or plane is actually gotten from slicing a cone. Okay, now depending on how the plane intersect the cone, different shapes are produced. So like the circle that was produced, imagine if I use a plane and then I slice this cone horizontally. Now if I slice a cone horizontally, we will have this, right? So you will see that the shape formed here will be what? A circle. Are we getting it now? Beautiful. So let's look at which other shapes aside circle that can actually be formed when a plane slices a cone. So the first one we said is a circle. All right. So the four major types, we have the circle, we have the ellipse, we have the parabola and the hyperbola, like just like I mentioned earlier. So now this circle is formed when the plane cuts the cone horizontally. All the parts are the same distance from the center. That's how we know that it is a circle. Now, when a plane cuts a cone horizontally, from the center to any point, you will see that it is the same, right? Remember what a circle is, all right? Locus of point equidistant from a fixed point. So from the center, that's a fixed point. Anywhere you take it to, you get the same radius or radar as the case may be. So that is a circle, right? By cutting this horizontally. Now, which other shape can be formed? We have the ellipse. Now, this ellipse we're going to be focusing on is very close to a circle. All right. Now, I'm going to tell you what things you can relate to on an ellipse. But since our focus for today is ellipse, let me quickly talk about the parabola and the hyperbola. Then we measure on the ellipse. Now, the parabola, you guys have, most of you, like if you've passed through SS1 and maybe SS2, you must have known the parabola. That's the equation of consider where the independent variable is y, right? Good. So now in parabola, you will see, or under conics, you will see the different parabolas that we can have. So this is where, depending on how you cut, remember that we have two cones joined together here. So now depending on how this cuts, on how you cut it, you can get different parabolas. So you can have where we can have the U shape that is under the x-axis. You can have the N shape that is above the x-axis. You can have the C shape that's on the other side. So now imagine if I have a cone and then I cut it this way. Yeah. You see, I just had one side of the cone cut. Now it didn't go round. That is why it forms either the C shape, the U shape, and all that. It didn't go round. It's not horizontally like the circle. Are you getting it now? Beautiful. And then it cuts this cone, just one part of the cone, at just one side. So now, like I said, depending on where it cuts, it can be cut in this way. The plane can cut the cone in this way. So depending on how it cuts, that's why you have different versions of the parabola. So when we get to parabola, we look at these different versions carefully. And then we have the hyperbola. Now this hyperbola is when if I use this plane to cut this way, maybe something like this, Did you see it now? Beautiful. Now, cutting these two cones at one end, at this end and this end. So that is why the hyperbola will always have two curves. Do you see that now? Beautiful. That's why the hyperbola will always have two cuts, because this plane has cut two ends of the cone. Now, the focus on today's class is ellipse. Now, an ellipse is formed when a plane cuts the cone at an angle but not steep enough to reach. See that? So this is exactly the shape of the earth and not this. All right? Good. So you have a whole lot of applications of this. So now, what are the important features of this ellipse? What are the important features? You would see that this cuts the x-axis at this point. So this is positive here. I have a comma 0. Then on this side of the x-axis, we have negative values minus a comma 0. So now, what is this a all about? This a is called the what? It's called the vertex. So now, since this ellipse is on the x-axis, the vertices on the x-axis is the major vertex or vertices. So we have the major vertices on the x-axis since the ellipse is on the x-axis. Now, this ellipse cuts the y-axis here. You have positive b, and then here we have negative b. Of the ellipse you need to know, we have the focus. Now, what is this focus? Because it is a very important aspect. So let's pick these points for our focus. So we have, since the ellipse is on the x-axis, we'll have our focus here to be c comma 0, and then here negative side you have minus c comma 0. Okay, now foci is a fixed point located inside an ellipse that determines its shape and its size. So if at any point on the edge of an ellipse you measure the distance, this distance, let's call here d1, and then let's call here d2. At any point you've put the d1 and the d2, if you measure the distance, the result will always be the same. All right, so now where is this foci always located? It's always located on the major axis. So since our ellipse is on the x-axis, the x-axis becomes our major axis. All right, so that is where our main vertices are. That is also where the focus is. So now, assuming that we have an ellipse on the y-axis this way, here becomes our what? Here becomes our A. So at this point, we'll have our 0 comma A. You know, the coordinate is x before y. And then here we'll have our what? Our 0 comma minus A. And then here we'll have our what? B comma 0. And then here we'll have our what? Minus B comma 0. Or you can just have it as minus B, whatever. So now, where will your focus? This remains your center. All right, good. Which is your H comma K. Now, where will your foci be located? Your foci will be located on the what? On the y-axis. All right. So we have our C comma 0, 0 comma C here, and then we'll have our what? Our 0 comma minus C here along the y-axis. So now these are the major things you need to know about your ellipse, how to represent your ellipse in a diagram. Now, let's pick a point on this ellipse. If we pick a point on this ellipse, point P, at this here, which is the major vertex, right? So now, using the Pythagoras rule, we have that a squared is equal to b squared plus c squared. So now, since in every equation, to find vertices is usually not the issue, is to find foci. So now, since foci is our point of focus, we take b squared to the other side, And then we'll have our c squared to be equal to a squared minus b squared. All right. So now for every ellipse given to you, to find the foci, if you square it, it will be equal to what? The square of the what? Of the major vertex minus the what? Minus the minor, the square of the what? Minor vertex, as simple as ABC. So if you take square root of both sides, you find your foci. So now, what is the equation of an ellipse? The equation of an ellipse, I gave you center h comma k. So when the center is 0, that is when h, the coordinates at the center h comma k is 0. We will have the equation to be, the standard equation becomes x squared over a squared plus b. Okay, so now in this case, our vertex here, just like we've explained, becomes plus or minus a comma 0, while our focus or foci becomes plus or minus c comma 0. These are the things we've established from the diagram. Then the co-vertex or vertices, I'm just using them like that, with 0 comma what? Plus or minus b. All right. Okay. Now remember, we are having this plus or minus because this is an ellipse. It cuts the axis on both sides. Okay. So if it doesn't cut on both sides, either it is a plus or either you have a negative or a positive, depending on which side it cuts the axis. So if it's on the y-axis, the major vertex becomes 0 comma plus or minus, while the co-vertex becomes 0. What will the standard equation be? So now we're going to be having x minus h squared over a plus y minus k squared all squared over b squared is equal to 1. That's just the difference. Then if it's on the y-axis, it will be x minus h all squared over b squared plus y minus k over a squared is equal to 1. The foci, the vertex, and all that will remain the same. So now let's talk about eccentricity before we quickly solve one or two questions. Now, eccentricity the eccentricity E is equal to C over A. That's the foci over the what? The vertex. Now, this eccentricity for an ellipse is less than 1. It usually lies between 0 and 1. All right. So when it is very close to 0, it means that the ellipse is looking closely like what? A circle. And when it is closer to 1, it is an ellipse proper, looking more oval in shape. So, we said that for a circle, the ellipse is 0. The eccentricity, rather, is 0. Now, this eccentricity measures how close this ellipse is to the center. A circle is at the center already. I don't know if you get what I'm saying. So now, if we go back to this, why when it is drawn on the board, it looks like a triangle. All right, but this is a 3D shape, right? So it is round. So if this thing cuts round, it has horizontally, it is at the center. All right. But now, if I cut it this way, just like this one, now imagine if this is at the center. We're now talking about how close is this cutting, depending on how it is to the center, to the horizontal. Are you getting it? So that is the eccentricity. All right. So now for a circle, the eccentricity of a circle is 0 because it is not, there's no gap, there's no distance or difference between a circle and the center of the cone where the plane has cut the cone. Okay, so let's quickly look at one or two examples. Under this example, we'll look at tangent, equation of tangent and normal as it relates everything you need to know about ellipse. Let's go. Over a squared plus I squared over b squared is equal to 1. We would see that to make this equation to be in this standard form, we have to make the constant to be 1. And the only way the constant can be 1 is by dividing through by 90. So if we divide through by 90, we're going to have x squared over 10, because 9 divided 90 will give us 10, plus, if you divide there by 90, we'll have y squared over 9. 90 divided by 90 will give us 1. So they now look alike, right? Good. Now after dividing, you check the denominators, what you have under x squared and what you have under y squared. So you will see that 10 is greater than 9. And our A must be greater than B because that is what determines where the major axis is. So now that is to say that this ellipse is on the x-axis. All right. So now our a squared is equal to 10, while our what? Our b squared is equal to 9, comparing both equations. So now to get our vertices, which is one of the questions asked, given that the ellipse is on the x-axis, let's first of all look at the major vertex. So if a squared is 10, that means a will be equal to the root of 10. And then 10 is not a perfect square, and there's no perfect square inside 10, right? So we leave it that way. Okay, so we have plus or minus 10. Then for the minor axis, minor vertex, we will have b. If b squared is 9, that means b will be the root of 9, which is 3. So we have plus or minus 3. Okay, so that means for the major vertex, we have root 10 comma 0, and then we'll have minus root 10 comma 0. Then for the minor axis, we'll have 3 to be equal to our a squared is 10, and then our b squared is 9. So subtracting, c squared is equal to 1. And when we take square root of both sides, c will be what? Square root of 1 is 1. So we have plus or minus 1. So that means our foci c, since it's on the major axis is x, we will have 1 comma 0 and minus 1 comma 0. Okay, so the difference is if it were to be on the y-axis, 0 will come first before the 1 and the minus 1. So for the eccentricity is c over a. So we've gotten our c to be 1, while our a is the root of 10. So you can go for okay, let me actually because I don't advise students to leave sword in the denominator. So let me just rationalize. I don't want to press calculator. So we have root 10 times root 10 and that will give us root 10 over 10. So I'm going to leave it like this. But then if you wish to get the real or rather write in decimal form, go ahead and find the square root of 10 and then divide by 10. All right, moving to the next question very quickly. We have a question that says we should find the equation of tangent and normal to the ellipse 2x squared plus 9y squared is equal to 18 at that point. So looking at this equation, you would discover that the center is 0, just like the first example we have solved. Okay, so let's go. Number 2. So we have 2x plus 9y squared is equal to 18, right? So we asked to find the equation of tangent and normal. So now equation, you know that the standard equation of this ellipse is x squared over a squared plus y squared over b squared is equal to 1. Okay, now when there is a point, that point. Okay, so now at the point 1 comma 4 over 3, we'll have our x1 to be 1. So 1 times x will give us x over 9. Then our y1 is 4 over 3. So we have 4 over 3 times y over 2 is equal to 1. So now I want to get an equation in its general form. So to do that, I'm going to multiply through by the LCM. Okay, so the LCM of 9 and 2 is 18. So multiplying through by 18, we would have 2x plus 9 into 4 over 3y is equal to 18. So this 3 divide this 9 will give us 3. So we have 2x, 3 times 4 will give us 12, is equal to 18. So now since there is a common factor in every term in this equation, I can actually reduce the equation by dividing through by that common term. So if we divide through by 2, we'll have x plus 6y is equal to 9. So this is the equation of tangent at point 1 comma 4 over 3. So now to get the equation of normal, what happens? Now equation of tangent, so the slope of tangent is perpendicular to the slope of normal. So just know this and avoid stress. The equation of tangent is what? Perpendicular to the equation of normal. So now this equation of tangent, writing it in this form so that we can pick our slope, y is equal to mx plus c. So that would be, I will have 6y to be equal to minus x plus 9, right? Okay, so I'm going to divide through by 6 so that the coefficient of x will be 1. So doing that, we will have y to be equal to minus x over 6 plus 9 over 6. So what is the slope? Compare this with y is equal to mx plus c. What is our slope? So our slope m is equal to what? Minus 1 over 6. So now since equation of tangent is perpendicular, it means that if the slope of equation of tangent multiplies that of normal, it will give us 1. So since we have gotten the slope of tangent and we're looking for that of normal, that means that slope of normal will be equal to -1 over the slope of what? Tangent. Are we together? Beautiful. So the slope of normal will be equal to -1 divided by what? -1 over 6. So first of all, the minus will cancel minus first. So since we have division, if you change it to multiplication, we'll have 1 times 6 over 1, and that will give us 6. So that means the slope of the equation of normal is 6. Okay, so y minus y1 is equal to, in 1 point form, because we have a point x1 comma y1, is equal to m into what? X minus x1. So we have our x1 comma y1, and we now have our slope. So let's substitute to get the equation of normal. As simple as ABC. Don't need to stress yourself. So y minus the y1 given to us, we have it to be 4 over 3, right? Okay, is equal to, our slope is 6 and our x1 is 1. So we'll have y minus 4 over 3 is equal to 6x minus 6. So in order to clear fraction, multiply through by the LCM of the denominator, which is 3. So we have 3y minus 4 is equal to 18x minus 18. Okay, so taking the 18x to the other side and taking the constant minus 4 over, we have 3y minus 18x is equal to minus 18 plus 4 will give us minus 14. Okay, so you can write it in this way, or it can be written as 3y minus 18x plus 14 is equal to 0. So at this point, we're going to be calling it a day. So in our next video, we'll continue with hyperbola and parabola. I hope you enjoyed the video. Do well to like, share, comment. Feel free to reach out with any question you would want me to assist you with. See you in the next class. Bye.